Well, class, of course, as you know, it is National Chemistry Week, and we've got a big event coming up on Saturday. And why do we celebrate it on this Saturday? Because of Avogadro's constant, very well known in chemistry, of course. 6,022 times 10 to the 23rd is Avogadro's constant, and so on October 23rd, we celebrate. Now, of course, anybody that's watching this show knows I'm not really a chemistry instructor, but on today's show, we've got a real treat for you, some chemistry experiments as part of Chemistry Day. Well, we promised you a little bit of chemistry, and now we're going to deliver on that promise. We've got Dr. Tamara Freeman here and a couple of fourth-year chem students, and we're getting ready for National Chemistry Week. What's that all about?
Yes, the purpose of this is to bring to the public an understanding of chemistry, why we become chemists, why it's exciting, and what it means to you in the world around you.
And so you've got an outreach program that brings people of all ages here to UBCO to check out the demos, or?
So it's fresh out of the gates, this outreach program. We've had some high school students come in and do some hands-on demonstrations. The event that we're hosting on Saturday is geared towards family with young children, so that we can get them to do some hands-on safe chemistry experiments to get them excited about science at a young age.
Well, what's up first?
Let's see, we're gonna do lava lamps, and I believe Justine will be in charge of this on Saturday. So this is her training session, so we're gonna show her how to do our lava lamps.
All right, ready, Justine?
I guess so.
All right.
So oil and water don't mix.
Right.
Oil sits on top because it's less dense. So you're gonna pour some oil. Top of what we have in our container is just water.
See, I know that much chemistry, the oil and water don't mix.
Just a couple of drops.
Yep, that should be good. So the food coloring is actually water soluble, so you'll see that it moves right through the oil and it goes down to the water layer. So this is what it should look like when it's set up. You've got your colored water on the bottom and you've got your cooking oil floating on top. The compound here that we have is an Alka-Seltzer tablet. You want to have a lot of surface area so you get a lot of bubbles. So you're going to break that tablet up. So all of that will dissolve, start to bubble, and then those bubbles will shoot colored water up into the oil.
Oh, it's starting to...
It starts...
Wow, it's very turbulent. Oh, that's exciting. That is so cool. So what is our next experiment?
We're going to do what we call slime for the little
Slime?
kids.
I like that.
This is a demo that we like to incorporate into the child education because it's a polymer demo, and polymers are incredibly important in our everyday life. So what we have here is some Elmer's glue, which is a certain type of long chain polymer.
Right.
What we've done is we've just diluted it with a little bit of water. We've added some food coloring because slime is always more exciting when it's green.
Yeah, green slime.
Yep. And so basically the reason the glue can run is because those long chains can slide back and forth across each other.
Okay.
What we do is we add a cross-linking agent. So that's this borax solution here, which is just a laundry detergent. What you'll see is that it actually starts to get kind of sticky. So now what we're doing is instead of a polymer that can only stretch in one direction, it stretches in all directions. Because it's just laundry detergent and glue, totally safe to handle bare hands.
Oh, okay.
Yep, you want to take that out? So there's our slime. So you can see that it stretches. The glue at first just ran because the molecules could slide past each other, but now they've been linked. If you pull really quickly, it'll crack because you're actually breaking those bonds.
That's very cool. Wow. All right, we're back in the lab with more chemistry fun. What are we cooking up next?
So this is a reaction that we affectionately call the traffic light. It's a color change reaction that demonstrates a principle that we learn in chemistry called equilibrium.
Right.
Most people assume that reactions only go in one direction,
Okay.
but they actually go in both directions. Sometimes it's just preferred to go one direction more than the other.
Right.
But this one is a reaction that goes in all directions.
Oh, okay.
So right now it's yellow. There's a compound in there that has a certain amount of oxygen incorporated into it, and when it's at that state, it's a yellow compound.
Okay.
So why don't I get you to give it a really gentle shake?
A gentle shake?
A gentle shake.
What?
So imagine you're at a traffic light and it's yellow. The next color that comes is red.
Look at that.
So a gentle shake turns it red. Basically what we've done is the oxygen in the air above the reaction is being incorporated in. So now there's more oxygen in the molecule, so it's now turned a red color. Keep going. There you go.
Wow.
The angrier you are at that red traffic light.
That's amazing. What?
Now we have much more oxygen. The vigorous shaking puts more oxygen into the molecule and it turns green.
Wow.
Different colors are different molecules.
Right.
Different molecules are attracted to this white powder in different ways.
Oh.
This should open. Oh, there we go.
Okay, so we're squirting the purple juice
Into our column.
Into our column.
So we're going to open up the bottom and try and make sure that we get all of that juice into the powder.
Okay, so now you're blowing air into it?
Yep, just to force it down, make sure it's sitting in the powder.
Okay.
Oh, you can already see that the colors are starting to come out.
What is this that we're adding?
This is berry pomegranate liquid water enhancer.
Berry pomegranate liquid water enhancer.
It's cheaper than Kool-Aid. There we
See
go.
it starting to separate there. You got 3 bands of color now.
3 bands of color.
Get that like pale blue and.
It looks like so basically what we've done is we've overloaded the column. There's too much purple, so we're not getting nice clean bands. But you can see that purple dye or food coloring, that whatever compound is making the 2 colors, the red compound travels much faster. It likes water a lot more than it likes the silica.
Right.
And the blue prefers to stick to the silica a little bit longer.
Okay.
So there we go, pure red at the bottom.
And you can have lots more experiments.
We are, yes. We have 6 or 7 for the day of the event. Lots of volunteers. We're giving out door prizes on occasion. We're also, which is always very exciting, making liquid nitrogen ice cream all day long. Different flavors.
Boy.
Strawberry, chocolate.
Liquid nitrogen is my favorite flavor.
Oh yeah, absolutely. So yeah, we have lots of volunteers. It's geared as a family event. At the end of the hands-on experiments, we're doing a live parody spy show.
Oh, all right.
So the theme actually for this year for National Chemistry Week is forensics. So we thought super spies who use their forensic capabilities would be a nice touch to that theme.
Nice. If people want to find out more, they can check the website.
There is a website, and we have an Eventbrite RSVP if you're interested in coming. The RSVP is only necessary if you want to attend the live show because we only have a certain number of seats in the auditorium. So it's elementofdiscovery.eventbrite.com.
Oh, awesome. Okay. Thank you, ladies. You excited about this?
Yes.
It's going to be fun. That is it for our show. I'm Doug Brown. Thanks for watching. See you next time on Go. And don't miss the chemistry stuff.